It is 04:14 hours local time. Russia's Varansk missile production plant is already drowning in fire. This is one of the most important facilities in the production chain for Kh-101 cruise missiles and Iskander-K missile systems. The same weapons Moscow has continued using to threaten Ukrainian cities from hundreds of miles away. But now the site, once protected like a military fortress, has turned into a towering column of flame rising into the night and painting the sky over Voronezh red. The secondary explosions were so violent that even seismic sensors near the Kremlin were reportedly triggered. Ukraine did not just hit a military factory. They struck directly at the place where the Kh-101 and Iskander-K missiles intended for future attacks on Kiev were being built. In only a few minutes, missiles that had been prepared to fly toward Ukraine were turned into blackened metal on Russian soil. And what shocked Moscow most was how this operation began. Not with a massive bomber formation, not with a long missile barrage, but with only 2 F-16s carrying false decoy traps, supported by 16 small unmanned aircraft, programmed intelligently enough to slip through multiple layers of Russian air defense and open the way to the target. To understand why the Voronezh missile production plant became a Ukrainian target, we need to look back at the days before, when the Russian military continuously increased the frequency and scale of its strikes using ballistic missiles, cruise missiles, hypersonic missiles, and unmanned aircraft against a series of major Ukrainian cities and strategic infrastructure facilities. These attacks struck directly at the capital key bases in Odessa, logistics routes, fuel depots, energy stations, and many nearby residential areas, causing heavy infrastructure damage and forcing Ukrainian civilians to continue living under air raid sirens, blackouts, fires, and destruction. In those strike waves, K-101 and Iskander-K were two names that put Ukraine on the highest alert. They were considered two of Russia's most dangerous strike weapons. The Kh-101 is a long-range cruise missile that can fly more than 3,000 miles, skim load to avoid radar, and carry a 1,000 load aboard warhead. The Iskander-K is a ground-launched cruise missile with a range of 3 km designed to strike command centers, military bases, ammunition depots, and strategic infrastructure. That is why Ukraine made a bold decision: strike directly at the place where they were made. The goal was to turn the Kh-101 and Iskander-K missiles Russia was preparing to use into useless blocks of metal on Russian territory, before they had even a chance to leave the launchers by a single foot. If Russia continued using missiles to destroy Ukraine, then the places producing those missiles would no longer be safe either. Russia did not leave the Voronezh missile production plant standing alone in the plains of southern Russia. The facility sits near railway lines, industrial zones, logistics depots, and most importantly, Baltimore Air Base, one of the key military sites protecting the airspace over Voronezh. Around the plant, multiple defensive layers had already been built. S-300 and S-400 systems scanned the sky from long range. Panzer S-1 and TORM-2 batteries stood ready to shoot down any UAVs or cruise missiles that slip through the outer ring. Electronic warfare systems were also active, prepared to jam navigation, cut communications, and blind enemy control signals. Kiev understood that it could not simply charge straight into a defense system like that. So, it did not choose a loud conventional airstrike. It chose a trap. 2 F-16s carrying false decoy traps would pull Russian radar eyes away from the real attack direction. At the same time, 16 long-range UAVs would fly low, slipping quietly into wars to search for the exact production lines, component warehouses, and preparation areas connected to Kh-101 and Iskander-K missile production. The chess game had begun. 2 F-16s and 16 UAVs against a missile plant, protected by the entire Voronezh air defense network and the defensive umbrella of Baltimore Air Base, at 01:23 hours local time, at a secret launch site in Sumy. The Ukrainian night was torn open by the steady sound of small engines in the darkness. 16 FP-1s left their launchers one after another. They were not large, not as fast as cruise missiles, and did not carry the intimidating presence of a fighter jet, but that was exactly what made them dangerous. Each one was only a small, long-range UAV worth $50,000, as difficult to detect, but capable of flying 1,000 miles deep into Russian territory and reaching targets Moscow believed were safe. Immediately after takeoff, the entire formation dropped altitude. The flight computers kept them close to the ground at only 230 feet, skimming over fields, forests, river lines, and open terrain stretching toward Voronezh edge. At this altitude, they were not trying to defeat Russian radar with speed. They were defeating it with silence, low flight, and timing. Over the next several hours, the 16 FP1s moved like black shadows under the night. Inertial navigation systems and anti-jamming positioning signals continuously corrected their flight paths, keeping the formation stable as they pushed deeper into Russia's air defense zone. But no matter how low they flew, 16's UAVs alone were still not enough to break through the shield around Voronezh. They needed something else, a diversion large enough to pull Russian radar eyes away from the real target. And that was when the first F-16 call sign Mirage appeared. The F-16 Block 70/72 Viper was no ordinary fighter jet. It was an airborne electronic warfare platform. It flew at a safe distance, close enough to force Russian radar to pay attention, but far enough to make the enemy air defense system hesitate. Under its wings were 4 AGM-OTT-weight missiles, weapons designed to hunt and destroy enemy radar emitters. Mirage's mission was clear: force Russian air defense to light up. But the real trick was not in the F-16. It was in the 280ms 1v60 MAL-JJ decoys released immediately afterward. Imagine you are the commander of an S-400 battery protecting for an edge. In front of you is a critical missile plant. Behind you is Baltimore Air Base, and on your radar screen, 2 large signals suddenly appear, approaching from the direction of Ukraine. They are flying high, emitting strong signatures, and looking exactly like a real air attack package. And exactly at 03:45 hours, local time, the F-16 showed them exactly what they feared most. From a safe distance inside Ukrainian airspace, the F-16 with the call sign Mirage released 2 MJS into the night. They were not attack UAVs. They were electronic decoys capable of imitating the radar signatures of fighter aircraft, making Russian radar believe that a large squadron was rushing in at an altitude of 30,000 feet. Within seconds, the air defense network around Voronezh woke up. Radars rotated at full power. S-350 and S-400 crews locked onto the targets. Baltimore Air Base shifted into alert status. On Russian screens, they did not see 2 small devices. They saw a major threat closing in on the interception zone. Then the launch order was given. 6 air defense missiles left their launchers, roaring into the darkness and racing straight toward the electronic ghosts high above. Each missile, worth $2 million, was fired only to chase a false signal. They did not touch the FP1 formation. They were pulled completely toward the ghost squadron created by the 2 MAJ devices. Because while Russian air defense was busy hunting targets that did not exist, the 16 FP1s were still flying low, only 220 feet above the ground, quietly slipping through fields, river lines, forests and redded gaps, leading toward foreign edge. That was Ukraine's trap. The F-16 did not need to destroy the plant. The MALJ did not need to carry a warhead. They only needed to make Russia look in the wrong direction for a few minutes. And those few minutes were all the FP1 formation needed. By the time Russian radar crews realized they had just fired millions of dollars in electronic ghost, their launch tubes had been depleted. The system needed time to reload, and the real threat had moved much closer to the Iskander-K production plant. If you were the battery commander at that moment, what would you do? Stay and let the short-range defensive layers handle it, or immediately call for support from Baltimore Air Base? Write stay or retreat in the comments, because while the Russians were still trying to understand what had just happened, Ukraine's 16 FP1s had entered the most dangerous phase of the hunt. But the Russians quickly realized that this was not the entire attack. The F-16 with the call sign Mirage was not operating alone. Behind it was a second F-16, flying lower, quieter, acting like an airborne marksman, waiting for the exact moment when Russia's air defense system was stretched to its limit, ready to turn Putin's supersonic pride into a massive furnace. At the same time, the 16 FP1s had entered the final 10 mi ring around the Voronezh missile production plant. This was the moment Ukraine's move became clear. The UAVs were no longer trying to stay completely hidden. As they approached the inner defensive ring, they began climbing just high enough for Russia's short-range radars to detect them. Why would Ukraine do that? Because this time, Ukraine wanted them to be seen. The FP1s became the final decoy layer, forcing Panzer S-1 and TOR-M2 to enter the fight. The short-range defensive systems around the plant immediately rotated their radars, locked target, and opened fire. Су-34 mm. Tу-95МС automatic anti-aircraft cannons roared through the night, creating a massive wall of fire at a rate of 5,000 rounds per minute. Short-range missiles left their launchers, climbing to intercept the small targets closing in. The sky over Voron turned into a maze of tracer fire, radar signals, and urgent commands. This was exactly what Ukraine needed: air defense saturation. When too many targets appear at the same time, even the most modern system must choose priorities. Radar attention gets divided. Operators become overloaded. Close-range fire is pulled away from the more important target. By sending the 16 FP1s in at exactly the right moment, Ukraine forced Russia's final defensive layer to pour its full attention into small gasoline-powered UAVs. And, while the Russians were busy firing at the targets directly in front of them, the second F-16 was still waiting for the moment to deliver the decisive blow. While Russian air defense crews believed they had just regained control of the sky over Voronezh, they had no idea that the most dangerous attacker was still hiding 50 miles away. It was the second F-16 call sign Ghost. If the F-16 Mirage created noise, released decoys, generated interference, and pulled the attention of the S-300 and S-400 up into the high sky, Ghost did the opposite. It only needed to fly low and silent like an airborne sniper, waiting for the exact moment when the inner defensive ring around the Voron missile plant was stretched to its limit. And that moment had arrived. The pilot flipped open the safety cover on the weapon release system. Under the aircraft's wings were 4 AGM-150 JSUM missiles, stealth air-to-ground cruise missiles, designed to penetrate heavily defended areas. This was not an ordinary bomb. Each JSUM cost 1 to 2 million, had a range of 200 miles, flew at a subsonic speed of Mach 0.2, and carried a nearly 1000 Lobozorov penetrating warhead. Think of JSUM as the special forces version of a cruise missile. Its body is built with angled surfaces to deflect radar waves. Composite materials help reduce its radar reflection. Its radar cross-section is so small that in a sky already chaotic with FP1s, MAJJS, jamming signals, and false alerts, it might appear only as a faint dot on Russian air defense screens. Then the launch order was given. 4 JSUMs dropped from the pylons under Ghost wings. In the darkness, their small wings unfolded. Their engines activated. They plunged lower, hugged the terrain, and began slipping through the radar gaps that Russian air defenses had exposed. At the same time, the Fincer S-1 and Torom-2 crews around Voronezh were still being dragged into the fight against the 16 FP1s. Those small UAVs had deliberately climbed high enough to be seen, forcing short-range radars to keep rotating, treated mm cannons to open fire, and short-range missiles to leave their launchers. The Russians thought they were striking the main attack. In reality, they were only firing at the final curtain. The real threat was flying lower, quieter, and far more dangerously. Electronic warfare systems near Baltimore Air Base began jamming. But that was no longer enough. JSUM did not need a pilot controlling every second of its flight. It used inertial guidance, digital maps, and an imaging infrared seeker in the terminal phase. In other words, Russia could jam signals, but it could not change the shape of the factory. It could not make the workshops, component warehouses, assembly areas, fuel tanks, and fixed structures already stored in the missile's memory disappear. While Russian batteries were still reloading after spending firepower on decoys and the FP1 swarm, the 4 Ghost bombs continued closing the distance. Each carried nearly 1,000 pounds of penetrating explosives. Altogether, nearly 4,000 pounds of destructive power was now gliding toward the place where Iskander-K missiles were produced. But that was not all. Ukraine had calculated that Russia might still have one final defensive layer around the plant. So, the final 4 FP1s were timed to rush in at the exact moment when Voronezh's defenses were at their most confused. Now, imagine you are the battery commander protecting the Voronezh missile plant. Would you keep your position and hope that radar, concrete, and anti-aircraft fire were still enough to stop the final blow? Or would you order an evacuation once you realized the entire factory had become one giant fixed target? But that question came too late, because in the next 30 seconds the physics of destruction began doing its work. The 4 JSUMs entered their terminal phase. Their infrared seekers locked onto the target structure. Their guidance systems made the final course correction, and the Voronezh plant, the place Moscow used to produce Kh-101 and Iskander-K missiles to threaten Kiev, Odessa, and many other Ukrainian cities, was about to become a massive furnace. At 0412 hours local time, the final 90 seconds in the existence of the Iskander-K missile production line in Voran began. Inside the factory complex, the air was thick with the smell of electrical smoke, industrial oil, and hot metal. Red warning lights flashed along the concrete corridors. Russian technicians rushed through the control area, trying to cut power, lock safety valves, and isolate the workshops under alarm. But it was already too late. The evacuation order was issued when the sky above Voransk had already turned into a chaotic maze of radar, electronic interference, air defense missiles, and low-flying FP-1 UAVs. The Voron missile plant with its missile assembly lines, guidance component warehouses, engine testing areas, fuel tanks, and KH-101, and Iskander-K missiles waiting to be completed could not disappear in a few minutes. That was exactly the weakness Ukraine had been waiting for. Outside, Russian air defense was falling into overload. The S-300 and S-400 had just been pulled upward by false targets created by the F-16 Ghost. Panzer S-1 and TR-M2 were being dragged into a fight with the low-flying FP-1 swarm around the inner defensive ring. Some launch tubes had already spent their ammunition. Radars had to rotate constantly between too many signals. The operating crews could no longer see a clear battle. They only saw chaos. And in that very moment, 4 JASMs from the F-16 Lightning entered their final phase. Now close to the target, the stealth missiles skimmed low through the night. Their imaging infrared seekers began locking onto large hit points on the factory roof, the main assembly area, the ventilation cluster near the component warehouse, the energy support area, and the workshops where missiles were tested before shipment. The onboard computers made one final course correction. There was no loud roar in the sky. No clear warning on the radar screen. Only 4 traces of death moving into the target. The first missile struck the assembly line area. It punched through the steel roof and detonated inside the main production zone. The blast pressure exceeded 150 pounds per square inch, blowing apart industrial partitions, collapsing metal racks, and bending load-bearing steel beams. In an instant, the place where KH-1 components had once been assembled turned into a glowing red furnace. The second missile slammed into the component warehouse where control units, guidance equipment, electronic parts, and testing systems were stored. The explosion tore through rows of steel shelving. Red-hot metal fragments flew across the building. Signal cables, circuit boards, composite materials, and electrical equipment caught fire almost immediately. Within seconds, the flames had surged 270 feet upward, curling into a thick column of black smoke over the Vorish sky. But the most terrifying blow landed in the area, holding missiles, waiting to be completed. The third missile struck just as the internal fire suppression system had already been overwhelmed. The first explosion was only the spark. The real horror began when fuel, flammable materials, and high-energy components inside the storage area started reacting in a chain. The temperature inside the warehouse surged to 3,500 degrees C, while pressure trapped between the concrete walls increased with every second, turning the entire building into a massive fire chamber. Then the secondary explosion came. An orange-white fireball burst through the factory roof, lighting up the entire industrial zone in the night. The shock wave swept across the complex, shattering windows, ripping open roof panels, and throwing heavy sheets of metal far away. Within seconds, the missile storage area was no longer a military warehouse. It had become the center of an uncontrollable chain of fires and explosions. The fourth missile struck the support area where pipelines, tanks, and energy systems were already shaking from the earlier blasts. Fire ran along the technical lines, swallowing smaller workshops one by one. Roof sections collapsed in pieces. Secondary blasts continued to echo as storage compartments, pressure cylinders, and flammable materials were pulled into the sea of fire. Inside the Ukrainian command center, there was no cheering, only tense silence and short reports sounding through headsets. Assembly line destroyed, component warehouse, major fire, support area out of control, missile storage area, secondary explosion. The Vorish target was no longer an effective missile production facility. What Moscow had once used to produce KH-101 and Iskander-K missiles to threaten Kiev, Odessa, and many other Ukrainian cities was now only a massive column of fire under the night sky. The missiles prepared to leave the factory never had the chance to fly. They died in the very place that created them. The result of this attack was not only in the columns of fire rising from the Voron plant. Its real meaning was that Ukraine had struck directly at a critical link in Russia's missile production chain. The Kh-101 and Iskander-K were not destroyed after they had already left their launchers. They were neutralized much earlier, right inside the assembly lines, inside the component warehouses, inside the testing areas, and inside the support systems that had not yet recovered from the first wave of explosions. Militarily, this was a completely different kind of strike. Instead of only defending against attack waves, Ukraine had shifted to striking the capability that creates those attack waves. That was what worried Moscow the most. A cruise missile can fly far, fly low, and create serious problems for air defense. But before it becomes a weapon, it is still a complex industrial product. It needs microchips, diodes, sensors, guidance systems, skilled engineers, testing equipment, and a stable supply chain. If only a few links in that chain are destroyed, the entire production rhythm can be slowed for weeks, even months. According to reports after the attack, the damage was not limited to the burned workshops. The core semiconductor and diode production areas of the Spra plant were destroyed. The supply of microchips for the Kh-101, Iskander-K, and even Panzer S-1 was disrupted. Many engineers and highly skilled technical workers became casualties, while the pressure from the explosion damaged nearby apartment buildings and residential homes. That showed the strike did not only create physical damage, it also injured the technical capability Russia would find very difficult to replace in the short term. From a military perspective, this was a strike deep into the rear. Ukraine did not need to destroy Russia's entire missile system in one night. They only needed to disrupt the production rhythm, slow the rate of weapons replenishment, force Moscow to spread out more air defense, increase protection around factories, and pull more resources away from the front line. Every battery sent back to defend an industrial facility is a battery no longer near the battlefield. Every production line forced to stop means fewer missiles that can be aimed at Kiev, Odessa, or other Ukrainian cities. More importantly, this was a strategic message. Targets Russia once considered safe because they were deep inside its territory behind multiple layers of radar and air defense are no longer completely safe. Distance still matters, but it is no longer an absolute shield against low-flying UAVs, electronic decoys, radar interference, and precision-guided weapons. For Moscow, the damage was not only a burning factory. It was time, money, manpower, prestige, and production rhythm being hit all at once. For Ukraine, this was proof that modern war is not decided only in the sky or on the front line. It is also decided inside factories, component warehouses, testing rooms, and industrial links far behind the battlefield. The Kh-101 and Iskander-K were created to spread fear from the sky. But this time, part of the capability used to create them was defeated on the ground. And that is the greatest lesson of this operation. A missile does not necessarily have to be destroyed while it is diving toward its target. It can be defeated long before that if the place that creates it is turned into ashes. Far behind the battlefield, the infrastructure of logistics, engineering, and continuous industrial supply remains the true backbone of long-range operations. By neutralizing these specialized production assets, the overall architecture of strategic strike capabilities undergoes an immediate and systemic contraction. The technical capacity to build, test, and field advanced strike platforms cannot simply be rerouted or quickly replaced when the critical hubs themselves are compromised. In the final analysis, the operation's outcome confirms that the deep interior of a state is no longer an isolated safe zone, and the balance of long-range engagements is now determined by those who can successfully target the very origin of the threat.